Well, hello friends. Welcome back to the program. Today, we are going to look at process backtraces. So currently, the way process backtraces work is that for every process, we can go into its proc directory in the stacks subdirectory, and here we find a file for every thread in that process. So in the shell that we're currently executing, we have this one file here that has it's just a text file with actually all the kernel addresses are symbolicated, but the addresses themselves are hidden, and then the user space things are not symbolicated because the kernel doesn't see user space symbols. And this file is the same thing that we would show you if you open System Monitor, pick a process that you have access to, and then look in the stack tab down here. So this is not ideal because you can't see what's going on in user space, and maybe you shouldn't see what's going on in kernel space unless you are root. So I think today we are going to do a bunch of things. So the first thing I want to do is I want to have all of the symbolication done in user space. So I want the kernel to not have to do any of this resolving symbols to, or resolving addresses to symbols. So we should only export addresses from the kernel, and then we need some kind of library, or better yet, a service process in user space that can do symbolication. So maybe like a symbol server that can keep a cache of already resolved symbols and things like that. And then System Monitor would connect to the symbol server and say, hey, can you tell me what these addresses are in these libraries? And we could also make like a nice command line command for this. So something like imagine if you could say like BT25 for backtrace 25, right? And it would print out like a beautiful backtrace with all the information that we can figure out from the addresses and from the ELF image itself. So yeah, so that's what we're going to do today. So I think we'll start by doing the kernel bits, where we change the format of the procfs file to only export addresses. So that would be procfs tid stack. So right here, this is the function that gets called when you read from one of these files. So you can see that it's just looking up the thread by thread ID and then building up this text file using a kbuffer builder. And I think we're going to do something slightly different here. So we'll make a JSON array serializer. And then we will iterate over the addresses in a stack trace from the thread. And we'll limit it at maybe 1024 frames. Okay, so I think this will give us a vector of pointers, yeah. Okay, so that's good. And then we can simply say array, add, something like that. Finish. So I think if you are root, then we can let you see the kernel addresses, but I think if you're a regular user, we're just going to obfuscate those. And we can just do that very easily here. So hide kernel addresses is process current. If you are, let's actually say show kernel addresses. So if not show kernel addresses, then and not is user address, then we will say that it's dead code. Something like that. So this should be very, very basic, but now we should get a JSON array instead in these files. So, and indeed we do. It's very uninteresting. If we pretty print it, we can see that these are all like hex dead code, right? So because I'm not a super user, I can't see where exactly in the kernel we are, although I can see how many frames there are, but I can't see where they are. And then I guess if we were to become root and do the same thing, then we can indeed see the specific addresses in the kernel. So that's good. Very, very basic, simple interface. So let's commit that. Proc pid stacks did a JSON array. Symbolic the contents are of these files are now pure raw JSON arrays. No, we no longer symbolicate the addresses. Yeah, that's up to user space from now on. Cool. Okay, and then let's make a symbolication server or a symbol server. So we'll go in userland services, and I think we'll start by just copying one of our existing ones. How about the image decoder? I don't know. I just need a template. Symbol server. Okay. And here, so we'll have symbol server and symbol client, I guess. So this is actually nice because a symbol server, not only does it allow us to cache symbolicated libraries and stuff so that we don't have to like do all the parsing again and again, but it also isolates the task of ELF library parsing to an isolated process, right? So there are obvious security benefits to that, like not trying to parse random executables in the system monitor, for example, but instead delegating that to a service process. So I already like this. Symbol server, let's call it. And we don't need libgraphics. We need libipc. And we get libelf for free because it's built into libc, actually, which is a little bit weird, but that's how it is. And I guess we'll rename image decoder client to symbol client IPC and symbol server IPC. Okay, so I think we're good with the renames here. Now we just need to edit some files. So symbol server main. It's a little bit of boilerplate, not too much. But it is what it is. So let's look at the symbol server IPC protocol. So first we have to give it a magic number. So why don't we, what is the ELF magic? I always forget. Hex dump. 454C 46. what would that be in decimal? Fancy. Okay, that is a very memorable number right there. And then what is the IPC request that you send to this thing? You send like symbolicate and maybe a path to a library? We can either send over a file descriptor with the library already opened, or we can give it a path and then this thing will go and open it. Maybe that's better. I think that's better. So path, and then we want maybe a vector of addresses. So we can say something like this for now. And it will just respond with a vector of like symbols, I guess. Yeah, so we could actually do a richer type here. We could have symbols and file names, line numbers, things like that. But we'll start with just this, just to get the basic mechanism going, and then we can add more metadata about each symbol. But I think this general API seems like a place to start. And then for the symbol client, I think we don't actually need any IPC going in the other direction, but we have to define a client anyway, because that's just how libIPC is like at the moment. Also, you cannot have a completely empty IPC interface, so we have to have a dummy. But there's no messages going from the symbol server to its clients. Like it's all done by this guy right here. Okay, so then I guess we are gonna also start this thing when you start the system. So in system server ini, so image decoder, we start here. Symbol server, socket temp portal, symbol. And let's see, I guess this can be lazy, user can be, I guess we can make its own user for it. Boot modes, it should be in all boot modes, I think. I don't want to mess with this too much. Also, like if I want root to run this thing, maybe it should start as root and then choose a different guy later. I don't know. Like the way that we'll get this thing to symbolicate kernel symbols, I'm not completely sure how we're going to do that. I'm thinking that if you as a developer want kernel symbols in your backtraces, then you can go into this file system server ini and configure the symbol server to run in a mode where like it opens the kernel on startup and then drops privileges or something like that. But we'll get to that much later, I think. For now, let's just not think about this too much at all. So I think this is probably fine. Also, image decoder is the thing that we copied here is actually like a single client server. So like we spawn a new instance for every connection. I think for symbol server we want it persist instead. So we want something more like oh man, who's who is a better one to copy? I guess somebody who accepts, like launch server, yeah. So you want something that looks more like this. So we need to pledge accept. Okay. I don't know if we need Unix. Yeah, the pledges we can probably reduce later on. We do need to be able to open files though. So rpath, and then we will unveil like user lib, I guess, and bin. Let's start with those two. There might be a case where we would want to send it a file descriptor of an opened executable as well. But let's allow it to look up system programs like this. So I'm imagining that we could have a policy where we always allow caching for stuff in /bin and user lib. But if you can provide your own executable, but then the results maybe we don't cache or something like that. I'm not really sure. I don't know. There are many architectural questions here, but let's not worry too much about that. So, okay. Symbol server, client connection, and okay. Just doing all the boilerplate here to convert the copy-pasted image decoder server into a symbol server. So we have a greet message, and we also have the symbolicate message. So almost there. Cool. Yes. So let's start with this. Stdio, rpath, accept, and I don't think we need Unix. Okay. So what will we do in symbol server client connection? Maybe we should have like almost like a project template or something for getting started with a new IPC server. I mean, it's still like very easy to build one, but there's a little bit of startup time, right? Like to do everything that I'm doing now just to get to the point where we have a usable thing. Symbolicate response. And here we are. Finally, we can start programming this thing. So, oh, when a client dies, let's not die. Okay. So we get a request, and let's symbolicate it. So what we want to do is we want to have a cache of libraries. So something like or cached binary, cached elf. And this will have a place for us to map it. And we also need libelf, elf elf image. Okay. So something like this maybe. All right, and then we will just put these in a global thingy, so hash map of string can be the path, and it points to a own non-null own footer cached elf. Okay, and for now let's just always cache everything. Let's not empty the cache just because, and then we can deal with that later. So first thing we do if we get a request here is path is message path. If scache contains, if it doesn't contain path, then we need to cache, open this file and cache it. So map path. If it's an error, then we have to fail. So we need a way to fail these requests actually. So we'll have something like bool success. Yeah, and then we can respond with false. So this is a little awkward, like the way that you signal failure, because you have to do something like that. But yeah, it's okay. So here we go, something like that. But if it succeeds, then elf is elf image. Takes read-only bytes. Okay, so mapped file value bytes. Cool. Cached elf is I guess we can. Just thinking we can actually do it like this. It's not really a big deal because it's just pointers. Mapped file release value and move elf. There we go. Oh, and I guess if the elf is not valid, then we can also fail. Okay. Scache set path move cached elf. Okay, so now we know it's in cache. Great. And I don't have a pointer to it. So, okay, this will be a little ugly. We'll just do a double lookup here for now. Path is not as cache end. Cached elf is. Okay, so now we have it. So now we're going to start doing all of the lookups. So if you recall, the IPC message was giving us a vector of addresses to poke into, or to look for. So we'll just go through them. Like this. And let's see, how does this work again? Cached elf symbolication. Oh, it gives us a string, cool, for the address. And, oh, optionally the offset. So let's also retrieve the offset The offset is like how far into a given function you are. So symbolicate u32. Okay, so offset. Okay, and then for now we will simply like drop the offset on the floor and add the symbol to our vector of symbols. And we can actually pre-size this thing since we know how many are coming. So we just do that. And then we don't need to dynamically grow the vector, like we only grow it once. Okay, so I think this is basically everything we need this program to do. So let's see, I guess we're gonna want a basic client library for this thing. So let's make something like that. Currently we have already like image decoder client, which is our most awkwardly named library. So why don't we have a lib symbol client while we're here? Our first library starting with an S. That's cool. And what do we do in here? It depends on the symbol server IPC code generator stuff, obviously. So we need to tell CMake about that. And the rest of this is just changing the name. Okay. So symbol client. So let's see what this API will look like. This is just going to be a helper library for interfacing with the symbol server. So we don't need any of this image decoder gunk. And here's that dummy function that we have to have. It'd be nice to get rid of that actually, but not right now. And this API, so what will the symbolicate API look like? It will be essentially, I mean, let's describe our dream struct that we want here. So symbol has a name, address, maybe like an offset, and a file name. And you know what? Let's splurge and include a line number. Okay, so yeah, all of these things would be super cool to have, right? At the moment, we're only going to be able to fill in the address and the name, but we'll start somewhere, right? So then the API will be something like void, or no, not void, vector symbol, symbolicate path, and a vector of flat footer addresses. Cool. So it's your job. Like, if you want to use this thing, you need to know which library you're digging into for the given set of addresses. So let's see how we would use this in our I mean, let's just flesh this out so that we have the inside of it finished, so we can call. But then it's going to be interesting to see how we actually use this, because it's not trivial to go from just the addresses to symbolicate calls, but it's also not super complicated. So we'll see soon enough. Okay, so vector symbol, symbolicate, here we go. So response is send sync messages symbol server symbolicate path addresses. Cool. And then if response success, if it's not a success, then we will simply return an empty vector for now. Maybe we could signal the error somehow more richly, but we'll start with that. But if it is a success, then let's make a vector of symbol to return. And yeah, like ultimately this should all be like done for us by the generated code, but for now we have to do this manually, so we'll just do something like this. So response symbols s dot name is symbol. Yeah, there we go. Okay, so how do we use this? Well, I wanted a BT program that will print the backtrace for any program, so let's try to make that. So how would that look like? Lib symbol client. And I guess we are going to use a libcore args parser to parse the args. I haven't used this in forever. How do you do it again? I forget. Let's relearn it. Positional argument, I guess. So we just want to take a PID, really. PID. Yeah, something like this. PID PID. Args parser parse. RC RGB. Is this how we normally use this? I have to look it up. Okay, all right, that's good. So I guess that's good, and then we have to make an event loop so we can call that other service. So we'll make the event loop here. Okay. I don't know if we need to execute the loop actually. I think maybe we can do synchronous IPC immediately. Let's test it out. So here we would do something like symbol client. Okay, this is kind of an awkward API. I mean, the name is awkward, right? I wish it would be called something more like symbol server client or some symbol client, maybe. It's not obvious to me what the naming scheme here should be, but let's not overthink that right now. Symbol client it is. symbolicate. Okay, so first thing we got to do is we got to open up the proc file for the thing that we want to symbolicate. So let's get file and JSON value and JSON array up in here so that we have them. And then let's see, core file open. Path is, or stack path proc stack is okay. Yeah, so for now we'll just this will only work on the main thread for now, but if there are multiple threads, then we should obviously allow you to get all of them or a specific one and stuff like that. But for now, we'll just make a fix me about this. Support multiple threads in the same process. Okay. Read only. Okay, so if that succeeds, if it's an error, then let's print a warning. Could not open. Problem was this. Return 1. Cool. So now we have the file. Let's turn it into a JSON array. So JSON value from string, file or error, value, read all. And if that is not valid JSON, or if it's not an array, then invalid contents in this thing. We can't handle it. Okay, so now we know we have a JSON array. So then we can simply construct a vector of addresses. Although we also need to know which elf to look in for each thing. So here's where it gets a little interesting. Okay. So in order to know that, we also need to look at the process memory map. So let's open that as well. Although we can suck in all the addresses into a vector, actually. Stack, let's say, and value in JSON value as array values. Stack append value to u32. Boom. Okay. All right, so now we have slurped up all of the addresses that we want to symbolicate. And then now we also need the memory map of the process so that we can figure out which elf file each of these addresses belongs to. So we need to open that up. That would be proc pid vm, something like this. So we can actually, let's just, let's see, we will move this up here, and then we can simply put all of that in its own scope like that. And then we have a brand new file or error without shadowing. File or error is core file, open VM path. Okay, and then if that is an error, then we will print a warning. Could not open, because, Sure. But if we could open it, then the format should be, let's take a look at it. So it will be an array of JSON objects that look like this. And in each one of these objects, which is one VM region in the process, we will have name and address and size. So based on the name, address, and size, we can figure out if this is an ELF. So these are all malloc blocks, but right here we have libm.so data. And so from this we can sort of work out if this is a library that we need to look into. So let's see. And maybe this logic here should be generalized into a helper as well. But right now let's just write it out so that we can see exactly what the steps are. Let's get the JSON. So JSON is JSON value from string. File value read all if has no value, or JSON value is not an array. Yeah, so we can't deal with that, otherwise we are good. So let's do something like this. Region value in JSON value as array values. Okay, so these should now be objects. I'm just going to assert at this point. As object. Actually, probably as object asserts for me. Yeah, so I can just do that. Name to string. Okay, I think we need to get JSON object up in here. And these will both be U32s. Okay. So, what exactly are we learning here? I guess we need to make a list of something. So, ELF region or something like that. Maybe we'll just call them region. Region with symbols. So we'll have a base address, a size, and a path. Path will be the path to the .so file. So now it's going to get a little murky here, but because the paths are not exactly encoded, it's more like the name of it will be like libc.so:text or something. So we have to do a little bit of finessing here to get what we want. But we'll do something like this. So if name contains .so:, actually, let's get a dump so we can see what they would look like. So they look like this, like libc.so:, space .text. So maybe that's what we would look for actually. So if like the name ends with text like that, I wonder what the main executable looked like. So this would be the shell. So here, this one actually looks a little bit different, which is a bit stupid, but the dynamic loader has like a different naming scheme. I don't know why it's like that. I don't know why we don't write out the full path of these things. Maybe that would be nicer. Here we have the executable, so it's like full path : .text. So I think maybe what we'll do is we'll check for this exact path. User lib loader.so. Then path is name. Else if the name ends with like : space dot text. Okay, this will be gross, but whatever. We'll refine this later. Name split, we'll split around the colon, and the path will be the parts, so the first part, and then if path does not start with a slash, then path is, oh my god, this is so like, this is so hackish, but whatever. User lib, so we'll just prepend that. Yeah, this needs to be like better so that these are like predictably named instead. Would be a lot nicer, but let's just deal with this right now. Path, yeah. Else we will continue. So, and then we are going to make a region with symbols. Base is address. Oh, wait. Path, okay. Boom. Whew. Okay, so what do we do now? I guess we can do one symbolication request at a time, just to, it's not going to be the most efficient. Like the most efficient would be to, I guess the most efficient would be to figure out everything we need and then send it over in one big bundled request. Second most efficient would be figure out every address in the same library that we want and send that over. The least efficient would be sending a request for each individual address, but that's what we're going to do to start with. So I'll just walk the stack like this. Client symbolicate. Okay, so now we need a path and the address or addresses. To which we'll simply append the address like that. That's fine. And then we need to locate in this regions collection that we have the region that contains the current address that we're looking for, which we will simply do like this. Region base, if address is greater than or equal to region base and address is less than region base plus size. Boom. Then this is the address. So something like this maybe. Found region. And if we don't find it, then we can't really do anything interesting. We can't symbolicate the specific one, so we'll just print out some question marks or something. So we'll do the address followed by question marks. Yeah, that seems fair. But if we did find a region, then finally we call the symbolication server, and then when he responds, if symbols is empty, again, we have to do the, I don't know what this is. But if it succeeds, then outline symbol and, I mean the address and the symbols 0 name both. Okay. It's a lot of code. Let's see if it compiles. Symbol client symbolicate. Okay. Oh, I need to say that I want to link with that. So target link libraries bt links with lib symbol client. Okay, everything just builds. Let's see if it runs. BT25. Ah! Failed to connect to temp portal symbol. Connection refused. That file does not exist. Interesting. So we failed to start that service. I guess I should have noticed that. What went wrong exactly? System server is not complaining about this. Oh, wait. I think because I have my own system server ini. Yeah. So let me remove that. I have an override one that I've been using. Okay, so now if we check symbol server is not running, but it should spawn lazily. At least that's what I thought. Portal is there. Oh, it's root. Okay, all right. I guess I need to run it as some different users. So I will run it as anon, as myself for now. Okay, so symbol server unveil invalid argument. Okay, what went wrong? Oh, wait. I'm not using this right at all. I have to say what I want to do with these things. There we go. I just want to read from bin and user lib. Okay, so here's our output. Seems like every symbolication request fails, but at least we're getting the addresses. So let's see what we're actually asking for. Symbolicating in this path. Address, found region path. And I have a feeling that we didn't find the regions, so no region found. Let's log that if that's the case. Okay, so we didn't find the kernel regions, but these things we did find. That's interesting. So these are looking like exactly like the request that we would want to send. So I guess we're good on this side. that's really good. So let's see what's coming in on the client side, or on the server side rather. To map elf not valid. Okay, successfully cached. And symbolicated symbols, addresses for path. Yeah. So we'll soon learn what the problem is. These requests look totally reasonable, but what is the problem? Symbolicated one address for All right, so he thinks that he's doing the right thing. I need to look. Wait, what are we doing wrong here? Symbolicate addresses, and then it is empty. Why is it empty? Client symbolicate. We're not. Response. Response or symbolication was not a success. Symbols. Let's see how many we think that we're getting. It was a success with 1 symbols. Am I just doing this something stupid? Name should be the one. Okay. Let's just log what we are assigning here. I don't know. Oh, wait a minute. We're getting question mark, question mark. Oh, that's so confusing. Okay, so the symbolication in the elf library returns question mark, question mark. So that was very confusing. So okay, that makes sense. So all the IPC stuff was working correctly, just that the symbolication itself failed. Oh, I guess because we're not giving it a relative offset, we're giving it an absolute offset. We need to subtract the base of the region that we are looking in. So here, we need to actually do, because of ASLR, like we have to turn it into a relative address. So if we just do that, we just subtract the base, which is randomized, then boom, we are in business. That totally works. That's pretty cool. And it's actually perfectly fast. Like, I guess we shouldn't sweat it too much. The fact that it's multiple IPC requests is not the end of the world. I mean, I can get so hung up on things like this, and then I just have to reality check myself and remember that, like, when I move the mouse, then there's this huge stream of IPC going between the Windows server and the terminal and everything. And then still though, like, I see this kind of thing and I'm thinking, ugh, so many IPC calls, it's terrible. It would be nice to make it batched and more efficient, but it's not as big of a deal as I imagine to myself. So this is really neat, though. This is really, really neat. So, if we are root, that doesn't really help us because, yeah, we can see the addresses now, as you can see here, but we still don't know, still can't symbolicate them because the symbol server doesn't know that it should look in the kernel. So I think we're not going to dig into that specifically today, but we will start doing some commits here. So symbol server, let's just set that up. And how do we want to run this thing, symbol server? So my gut instinct is to run this as an unprivileged user. So I think that's what we're gonna do. We're just gonna make a dumb symbol user. Because that's how I like to roll. And we'll give him his own group as well, because that's also how we like to roll. And then we let Anon be in that group so that Anon can talk to the symbol server. Let's see how this comes out. If you look at temp portal symbol, yeah, so it's symbol, but Anon is now in the symbol group, hopefully, right here. It's kind of goofy that these groups are not sorted. I should probably make the output from ID sorted. But this still works, yeah. So that's really cool. I really dig this. So we have, like this command now opens proc 25 stacks 25 and gets all the addresses, and then he opens proc 25 VM, figures out what elf binary is loaded at each of these addresses, and then figures out the relative address of each of these things in that elf library or binary, sends it over to the symbol server, which then parses the elf and returns back the name of the function at the address. That's pretty nifty. So no elf parsing has to happen in this program. It is protected from that. And that means that we can also pledge this program. So let's try to do that. So what do we need in here? We need stdio, obviously. We need rpath for /proc stuff. We need Unix to connect to the symbol server. Probably something more that I'm forgetting, but let's try this. I guess because I'm making an event loop, I need a few more things. So I need like fatter and path, or is it path? You know what? I don't remember which ones it is, so let's start it up and see what it complains about. Bloop, fatter. All right. And who else is it going to be? Oh, nothing else. Just stdio, rpath, Unix, fatter. That's cool. Okay, so then let's also unveil. So we need to unveil proc. And we also need temp portal symbol, and we want to connect to it. And then we don't need anything more, I would think. So this should be a nicely sandboxed program. Ah, almost. What did we mess up? Temp portal symbol has not been unveiled with R. Okay, so I need RW. I need RW to bind, I guess. I would have expected I need write permission to bind. I'm not exactly sure if either of these makes sense. Like maybe binding, or maybe like using a local socket should have its own unveil character. I haven't thought super much about that, but bind permission denied. Why? Oh, we're trying to make our inspector socket. Okay, at some point I need to do an overhaul of the way inspector works as well, because I would like it to work quite differently, so that every process doesn't need to create like a socket on startup, and but that's a whole other story. Okay, so this is good. This is still very, very tight. So let's continue with simply adding the symbol server. Add symbolication service for out of process elf parsing. This patch adds symbol server, a service daemon that provides symbolication of elf binaries. It has a very simple XC API at the moment that only turns addresses into symbol names. This will be this can be used to implement symbolication without having to do in process elf parsing yourself. Okay, and then let's add a little helper library. Lib symbol client, add a helper library for interfacing with symbol server. Cool. And then finally a little BT program. Add a little backtrace program that that uses symbol server. Yeah, so usage BT PID. This program will print a symbolicated backtrace for the given PID for the main thread of the process with the given PID. It uses symbol server for the symbolication. There's a lot of room for improvement in this command, but it is pretty neat already. Yes, okay, so that's pretty neat. And if we wanted to do this in the thread stack widget, because now if we look in System Monitor, it'll be pretty empty up in there. What am I doing? Here, stack, right? Like this looks super boring. Right now it's just showing the raw JSON array. So obviously that's not super great. But I'm actually out of time right now. So I'm gonna have to fix up System Monitor to use this later on, but I won't be able to do it today in the video. So we have to end it here. So we didn't do the GUI part, but it will be just more of the same, really, just using same mechanism, but in the context of process, in the context of System Monitor. And we didn't get to doing anything about the kernel symbols, but that gives me a chance to think about how that should work, so that's cool. Anyway, I'm still happy with the progress, and some things to add in the future are file names, line numbers, because it would be cool to see like which exact line and which exact C++ file every symbol is. So room for improvement, but still I'm very happy with the progress. I like the architecture a lot. So yeah, if you made it this far, then I thank you for watching and for hanging out. And I hope that you saw something interesting here today. I think we built something pretty neat, the start of something neat. And I'm going to keep iterating on this. So thank you for watching, and I hope to see you next time. Bye.